Here's number 5 from the quiz review. We start off by factoring. So we're going to factor out a -1 out of the numerator. So we have x squared plus 5x plus 4. Denominator, we can factor the trinomial into x minus 4 times x plus 1. And then the numerator can be factored a bit further, and we have x plus 4 times x plus 1 over x minus 4 times x plus 1. Well, we see we have a whole here at x equals -1. Let's not forget to put that in at the end. In fact, let's write it down here also, just so we don't forget. Our x-intercepts are the values that make the numerator equal 0. So that's at x equals -4. And vertical asymptote at values that make the denominator equal 0, which is x is 4. Our horizontal or slant asymptote, well, it is a horizontal asymptote. We see here that the degrees are both 2. And so when they're equal, the horizontal asymptote is at y equals the fraction of the leading coefficients, or the ratio of the leading coefficients. So it's really just a -1 over a 1. So -1 over 1, which obviously is -1. And the y-intercept. The y-intercept is what we get when we plug in 0 for x. So let's put in 0 here, 0 squared, minus 5 times 0 is 0, 0, and 0. So we have -4 over -4, and the y-intercept is 1. Let's go ahead and plot these things. We have an x-intercept at -4, vertical asymptote at 4, horizontal asymptote at y equals -1. And we have a y-intercept at 1. So because of this x-intercept and y-intercept here, we see to the left of our asymptote has to be above the horizontal asymptote. And it goes up. It can't go down because we don't have another x-intercept. And then on the right side of the asymptote, we can see that the branch on the right side will be down here for a couple reasons. First of all, our asymptote was degree 1, and so it's odd. 1 is odd, so the branches have to go in opposite directions at the vertical asymptote. And then the other reason is it couldn't be up here because it would have to cross the x-axis again, and there's only one x-intercept, so it's not there either. So there is the graph. We still have a hole that we need to include here, so there's a hole at x equals -1. So when x is -1, we're going to go ahead and put a hole there. And there's the graph of our function. Again, we could be a little more accurate if we plugged in different values. We could even find the value of exactly where that hole is by plugging in -1 into our canceled one here. So -1 times -1 plus 4 over -1 minus 4. So putting it back in to our reduced function, we get -1 times 3 over -5, which is 3/5. Pretty close. All right, so 3/5. And there's the graph for number 5.